Hi there, thanks for joining us. This is Space Nuts yet again. My name is Andrew Dunkley, your host. It's so good to have your company. Coming up on this episode, we've got a lot to get through, as I tend to say. Some clever work reveals where most meteorites come from. Some space scientists have doubled down on a brown dwarf mystery. What does that mean? Snow White? Snow White might know the answer. And some good news and some bad news for SpaceX. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Joining me again is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you going?
I'm going that way. Yeah, I'm good. I'm good at the moment. All is well. How are you?
I'm going that way too. Good thing we're both going in the same direction.
Yes, it is. Yes. Yeah, you don't want to be going backwards at this stage in our lives. It's
No, that's absolutely right.
very true. Unless you could wind back time and get younger and yet take back all that knowledge you've got and, not make the same mistakes over again.
No, I don't want to do that. I've had enough of making mistakes.
You'd just make different mistakes, I reckon.
I think you do, yeah. It's usually the kind of mistakes you make is, where did I put my glasses? I can't remember.
Oh, yeah. Yeah, I've done that. I can't find mine now.
I'll give you a clue.
Let me just adjust my glasses. And what was the answer?
Yes, that's right.
Judy and I have often talked about this and looked back at some of the mistakes we've made, mainly financial, over the years. And we've both said, look, if we didn't make those mistakes, other things wouldn't have happened that have defined our lives. So, you can't sort of dismiss the mistakes because they made other good things happen. You've got to think of it that way. So
that's the only way I can reconcile my past history with any kind of satisfaction. But some of the mistakes have resulted in some brilliant things.
Yes. Well, to err is human, and that's the definition of a human being. We make mistakes and hopefully learn from them. We're going to learn something now, Fred, from some very clever work that's been done, and they reckon they have nailed down around 70% of the meteorites that we know of coming from three basic events in recent history. So that's pretty exciting. And I think they extrapolated some more information out. They can nearly account for 90% of all meteorites. This is quite an amazing story.
It is. And it starts off with a kind of analysis of meteorites because they're not all the same.
No.
Astronomers or planetary scientists, I guess, classify them in different ways, which is all about their composition. The stony meteorites and metallic meteorites, they're the two sort of basic ones. But within those definitions, there are different, different levels of how stony they are or how not. And I should just say at the outset that the metallic ones are actually quite rare. So that the most common meteorites that we found are something called, ordinary chondrites. Chondrites, Chondrites. Looks like chondrites, but it's chondrites usually. And they are what make up most of the tens of thousands of meteorites that are in collections around the world. I can't remember the exact number, but it's a lot. Which have, they've been collected by meteorite hunters. And of course, they're free gifts from the universe, so they're always valuable to have because they tell us about the makeup of things. Anyway, the most common are these chondrites, which are sort of carbonaceous. They're stony objects. But the conundrum is that when you look at the asteroids, and they sit in the asteroid belt principally, and we believe that they are the main source of meteorites. There are one or two meteorites, actually it's several hundred, but a few that are known to come from the Moon or Mars, or in fact the asteroid Vesta, which is actually quite a large member of the asteroid belt, the fourth one to be discovered. I think 6% of all meteorites come from either the Moon, Mars, or Vesta. However, as I said, most of them are just chondrites. But here's the thing: the asteroid population, the chondrites are actually quite rare. They don't dominate the asteroid population, and so there is a puzzle there. Why should all ours be common or garden chondrites, whereas chondrites are relatively rare when you look at the asteroid belt in general?
Okay.
And so what this team, it's actually, I think, 3 different teams of scientists who've produced, I think there are 3 papers involved here. And what they've done is they've basically looked at the motion of the asteroids in the asteroid belt. And, you know, one of the wonderful things that you and I talk about a lot is how predictable gravity is. The fact that we can actually get a really good idea of the motions of objects through space, tens of thousands or even millions of years in the past and the future, because gravitation is such a well understood phenomenon, at least at the level of objects in the solar system. And so what they've done is they've studied the asteroid belt and looked for events in the past that would have brought asteroids together, that would have been collisions. And they've essentially found some, and they are collisions between chondrite asteroids. So it's making sense here that you've got a relatively rare population within the asteroid belt, but they are the ones that have collided. And they identify, I think, 3 collisions over the last. Actually, they go back quite a long way. There's one. The most distant one in the past, a collision, which I think we've talked about already, actually. I think we talked about it in a different context a few weeks ago. It's about 466 million years ago. And we think that was a collision that absolutely showered the Earth with meteorites and may even have formed a ring round the Earth. And I think that's what we talked about because there's an ice age not long after that, and the thinking is that the ring of asteroids around the Earth might have shaded the sun, the planet a little bit to reduce the temperature. So that's the furthest one, but there are other collisions that have been identified which are more recently than that. And I might read a paragraph, if I may, from a very nice piece on this from Sky and Telescope, one of the greatest astronomy magazines in the world. I was addicted to Sky and Telescope when I was a youngster. And what it says is 2 collisions involving H chondrites. These are 2 different sorts of chondrites, H and L chondrites, but they're all sort of common and garden meteorites. 2 collisions involving H chondrites occurred so recently that the researchers could trace their orbits well enough to date the family's origin. This is the family of asteroids that resulted from that collision. The older collision occurred 7.6 million years ago and yielded the family of objects with orbits similar to 158 Coronis. Now, 158 Coronis is an asteroid. You remember that asteroids have a number, which is the number in the order of discovery, and Coronis is the name given by the discoverer. So 158 Coronis. They seem to have come from a collision, Coronis and its similar family, a collision 7.6 million years ago. Reading back again from the Sky and Telescope article, a younger family dates back to an event 5.8 million years ago in which Coronis underwent another major collision, splitting off the smaller asteroid 832 Charon and its family. And so, this is lovely detective work that gives you a picture of the dynamics of the asteroid belt that we just didn't have before, and gives us a really good understanding that some of this debris that we receive from space really comes from a very small number of collisions in the asteroid belt.
Yeah, it's fascinating. Yeah, and I'm guessing after reading through the article, this still has to be peer reviewed. The paper is out there to be analysed and chopped up and debated, and Others will probably study the claims and say, well, hang on a minute. But they seem pretty confident.
Yeah, they do. I think these are pretty, and there are 2 Nature papers involved. That's obviously one of the leading scientific journals in the world. There's a lot of detail to this. It's a story with many twists and ins and outs. And what I've told you is the kind of the bottom line. But it is worth a read. It's very nicely put for astronomy enthusiasts in perhaps one of the principal magazines for astronomy enthusiasts, Sky and Telescope.
Yeah, I'm just amazed that you can look at a situation and go, okay, how did that happen? And then sort of work backwards to a source billions of years ago. It just fascinates me. I think it's very clever. As you said, very clever detective work. Yeah. And that's in Sky and Telescope magazine if you want to read up. While we're talking about meteorites, Fred, I read an article the other day, which I think the BBC Science website ran, about Earth getting bombarded by micrometeorites, which are tiny pieces of asteroid. And they reckon between 20 and 60 million kilograms falls on Earth every year in micrometeorites. And if you were to I don't know who worked this out, but if you were to stand in the same spot for almost 13 years, you would get a micrometeorite caught in your hair. There you are. There's a factoid if you like, but
that's of course assuming that you have hair.
That's right. If you don't, it would probably bounce off and land in someone else's hair. Maybe the case.
Yeah, that's an interesting article, and it kind of sparks memories for me of when I was in Edinburgh decades ago. There are things called Brownlee particles. Did that crop up in the article? Do you remember?
I can't see the word there. I can see a couple of other interesting little tidbits, like there's a 1 in 4,600 chance of being hit by a micrometeorite if you stand in the same spot for 24 hours. You wouldn't know it.
No. Well, if you stood in the same spot for 24 hours, I think you probably need therapy anyway after that. So.
You're probably in line for Taylor Swift tickets. That's probably where you'd be.
Oh, that could be it. That could be it. Yes, that could be right. No, great stuff. That's an interesting factoid. We should put that in Fred's Flippant
Fred's Flippant Factoids, which we started doing on our TikTok. If you want to look us up on TikTok when we do little previews of the shows. That's an interesting story, as is this one, Fred. They've been studying a brown dwarf for the last 30 years, but there's something about it that was off. So they've taken a closer look and wham, bam, thank you, ma'am. It's not 1 but 2 brown dwarfs. They've only got 5 more to find.
Yeah, and there's actually it's a good question what the population of known brown dwarf stars is. It's very high. It's a subject that we haven't really talked about much, Andrew. And it's probably not a very good thing that we haven't talked about it much, because certainly one of my former colleagues at the Australian Astronomical Observatory, Professor Chris Tinney of the University of New South Wales, he began his career as one of the world's leading experts on brown dwarf stars. He's now moved on to exoplanets, which I guess are the next step down the series, because brown dwarfs, in a way, they sit in size between the giant planets of the solar system, for example, or any other solar system, and stars themselves. They're defined as having a lower mass limit of 13 times the mass of Jupiter. And that means that if Jupiter had grown to be 13 times its present size, it would have not been a planet, it would have been a brown dwarf. And the difference is that brown dwarfs have low-level nuclear processes going on in their interior, something called deuterium burning, which gives them enough of a temperature that they're visible in the infrared, the redder than red waveband. So that's how brown dwarfs are found, using infrared telescopes. Back in the day, it would be in the 1980s and 90s when brown dwarfs first started to be being discovered, this new population of stars that didn't quite make it because they're not big enough. I think they need to be about 90 times, 100 times the mass of Jupiter in order for, what we call hydrogen fusion to take place, the normal processes that make stars shine. Anyway, that's the background. So this is a brown dwarf, which is called Gliese 229b. Gliese was an astronomer who made a catalogue of these things. And in fact, the discovery, exactly as you said, 30 years ago nearly, discovered in 1995, and is one that has puzzled astronomers because they couldn't really work out why it was so massive and so dim. If it was the mass that we thought it was, it should be a lot brighter.
I went to school with a couple of kids that fit that description.
Massive but dim. Yeah, okay.
You didn't argue with them. Ever.
Right, so, yes. Yeah, I can well imagine. I don't just, we probably shouldn't name them.
No.
Because that might get us into all kinds of
I would never mention Paul's name.
All right, let's move on. The brown dwarf Gliese 229b should be brighter than it is given its mass until now. And now we have had a paper that's been authored by actually a graduate student, which is, it's nice to see these postgraduate students doing their basically cutting edge research. And this gentleman, Jerry Kwan, who is at the California Institute of Technology, and Jerry can be either, so I should just qualify that by saying this person, Jerry Kwan, is a graduate student at Caltech, the California Institute of Technology, one of the leading organizations in the world for this kind of work, and lots of other fields of study too. Anyway, he or she, they have written a paper in Nature which explains what the issue is, and it's that Gliese 229b isn't one, but is actually two brown dwarfs. 38 and 34 times the mass of Jupiter, and they have a 12-day orbit around each other. And something close to our heart here in Australia, they were observed by using instruments at the Very Large Telescope in Chile, run by the European Southern Observatory, which we in Australia have a strategic partnership with now. So the fact that this star is actually not a single star, it's a binary, which is what we call two stars orbiting around one another, is a great discoverer. It's a great discovery and pushes forward our understanding of brown dwarfs. In fact, it clearly solves a problem. If this thing was more massive than it should be for the amount of radiation that it gives out. So yes, really very nice. A very nice study. There's a nice quote from one of the people who actually discovered Gliese 229b back in 1995, Rebecca Oppenheimer, who says, "These two worlds whipping around each other are actually smaller in radius than Jupiter. They'd look quite strange in our night sky if we had something like them in our own solar system. They would indeed."
Yeah, wow. No, that's a great discovery, and it sorts out a problem about this thing they've been looking at for 30 years not being bright enough, and they've figured it out. And Jerry is a bloke, so look, forgive me, Fred, but I think the Chinese pronounce their X's as sh, so it's Xuan. I would suggest his surname, Jerry Xuan
from Caltech.
Yep. Yes, originally from China and ultimately into Canada. But great. Very good pickup by him about the brown dwarf situation. How close is the nearest one to us? Have we ever figured that out?
Oh, yes, we probably do know that, and it's probably not that far, but I don't know the answer to it. I'm sure while we're talking about the next story, you can Google closest brown dwarf to Earth.
You know I will.
I know. And I'm glad you do, because, as we've just discovered, it's very nice that you can fill in these gaps.
The nearest brown dwarfs are located in the Lumen 16 system, which is about 6.5 light years away.
Yeah, I thought they would be quite close. I mean, it's because we have a relatively nearby population of brown dwarfs, so they're probably very common in the galaxy. It's because they're not at great distances that we know about them at all, because they are so dim. They're kind of brown. That's why they got their name.
Yeah. Not weak enough to be planets, not strong enough to be stars. They're just somewhere in between, wondering about their identities.
Probably. They're probably all kinds of
very confused spatial objects. Yeah. If you want to read all about that, it's in the Cosmos magazine website. This is Space Nuts with Andrew Dunkley and Professor Fred.
0G, and I feel fine.
Space Nuts.
Okay, Fred, we've got a couple of stories involving SpaceX. We've been talking about them a lot lately, and in this case, there's some good news and some not so good news. Let's start off with the good news about SpaceX making so many inroads in rocket technology.
It's really quite amazing what SpaceX has achieved. Last week, as we stand at the moment in late October, SpaceX carried out its 99th operational flight of the year. And that was another Starlink launch. 20 Starlink satellites launched from Cape Canaveral, and basically a successful mission. The booster had already flown 16 times beforehand, and made, after its 17th flight, made a good recovery on the drone ship, which is called, just read the instructions.
Yeah, I love that.
It's great, isn't it? Yeah. It's really quite remarkable. So the Space Coast, as it's called, where Canaveral is, 71 so far this year, because SpaceX also launches from other places as well. Yeah. So 71 from the Space Coast, of which all but 5 of them have been flown by SpaceX. It's quite an extraordinary track record. In fact, one of them was one we saw when we were in Florida back in May. The other 5 were flown by the United Launch Alliance. But, that statistic in itself tells you how much of a game changer being able to recover your booster rocket is. And that, because that's what gives SpaceX the edge on this, that they can pull the booster rocket back and launch it again.
Yes.
And of course, there've been other missions. The breakdown is of the 99 launches is 91 Falcon and 5 Falcon Heavy missions, and I don't think that includes maybe it does the Starship launches. I can't remember how that fits into the statistics. The Starlink launches, which of course culminated in that extraordinary event a couple of weeks ago when the Starship booster, the Falcon Super Heavy, was grabbed by the chopsticks.
Oh, yeah.
Down there at Boca Chica in Texas. So, yes, that's the good news. A lot of activity.
Yeah, they reckon, Fred, that they could reach around 144 launches by the end of this calendar year, which would be an all-time record. That would, an amazing achievement. I think they're launching on average once every couple of weeks.
It's more like, yes, it's
more than that.
It's more than that.
Twice a week.
Right. It's
3 times
twice a week, basically. 3 times a week. Yeah. It's a lot. It's kind of almost every day, which is sort of it's not quite that, but it's what we expected would happen with all this. Now, of course, most of those launches were for Starlink satellites.
Roger, your lots are here also.
Space nuts.
Therein, though, lies a problem, and this is where we get onto the not-so-good news for SpaceX, because people have been analysing their activity, and it's not just them. There's a lot of organisations that use similar technology, and the concerns have been raised about pollution in our atmosphere.
That's right. This is something that's been growing in, I guess, attention over the past, few months, perhaps the past year, is what happens when a spacecraft re-enters the atmosphere. So it burns up if it, unless bits of it actually get down to the Earth, which we do know happens from time to time. We've talked about that as well. Yeah. But the fact the spacecraft burns up, if you've got a Starlink satellite, which weighs about a quarter of a ton, about 3 meters by 1 meter, they basically are completely burned up in the atmosphere. And that means there's a quarter of a ton of stuff gone into the atmosphere. And the stuff is mostly aluminium oxide, because they're mostly made of aluminium. They burn up and generate aluminium oxide. And that is, it's one of these gases that contributes to the hole in the ozone layer. And so it is not that gentle on the atmosphere. There's an estimate which is that at the moment about half a ton of burned up satellite trash, as it's called, by some of the authors who've written about this, and I'm looking at the space.com website at the moment. Satellite trash, half a ton comes in per day. And that's because you've got, a lot of Starlink satellites burning up. They're a quarter of a ton. But you've also got the upper stage of the Starlink launch vehicle. So it's the top part of a Falcon Heavy, the bit that does not get returned to Earth. It's the cheaper bit. I think it weighs about 4 tons when all the fuel's out of it. And so they're coming down as well. So if Starlink are launching 20 at a time, which is about the standard number at the moment, then that every 20 satellites, you get another 4 tons of debris, which is the aluminium oxide that comes from the upper stage of your rocket. And that's it's a concern. It's starting to worry people, as I said, particularly it's in regards to its effect on the ozone layer. Now, you and I have talked before about the lifetime of Starlink satellites. They are about 5 years, and you will recall probably that the first tranche of Starlink satellites was launched in May 2019. That's 5 years ago, more than 5 years ago. So they are starting to come back. And
this is going to constantly rotate over time.
Yes, that's right.
They're going to be launching more than they're getting back that have passed their use-by date. So they come back and burn up. They put a bunch more up there. They ultimately want to put 100,000 of these things in orbit?
It could be 100,000 when you add in all the different constellations. At the moment, Starlink's 12,000 aiming at, but with possible extension of another 30,000 spacecraft in phase 2. I don't think it's called that anymore, but it was called that. But then on top of that, you've got OneWeb, which has something like 600 spacecraft in orbit. You've got Kuiper, which is another of these constellations. Qianfan, which is the Chinese answer to Starlink. That's 14 or 15,000 satellites. And when you add all these up, it could be that by the end of the decade we have 100,000 satellites in orbit, which would actually impact on the night sky very significantly.
Well, that's the problem. One problem for observational astronomers is the pollution that creates for observations. But all of these things are going to come back down. They're designed to come back down and burn up on re-entry, and we're putting all that aluminium oxide into the atmosphere. And I read the word, but it's escaped me. But it basically means that with the effect this could have on the ozone layer, it would affect the albedo, ability for our planet to reflect sunlight. So this is yet another potential greenhouse effect problem.
Yes, that's right. Indeed, that's right. It's clearly shaping up to be an environmental problem that is a direct result of the space age. And there's not many of those that you can point to. A lot of people think it's the exhaust gases from the rockets, which in a particular way it is, because solid rocket fuel is very bad for ozone depletion. And apparently the solid rockets that are used for some of the launches, United Launch Alliance's Atlas V uses strap-on solid rocket boosters. China's Long March 11 has solid rocket fuel boosters, and actually the new Ariane 6, the European one, also has these strap-on boosters, and they give out chemicals that are pretty horrible. There's chlorine in there and alumina, all sorts of stuff. And the worst of it is that they are putting these exhaust plumes into the stratosphere, just basically where the ozone is. So it's a really bad effect on ozone depletion, more so actually than the burning up of re-entering satellites. So this is all looking like a pretty gloomy story for space, that we're putting all this stuff into the atmosphere that we could probably do without.
Well, unless somebody in authority acts quickly and says, okay, you can't do that anymore. We know what could happen. We don't want that to happen. You're going to have to find another way. It sounds like a simple answer. I'm sure it's not.
No, it's not. I mean, you're kind of reduced to something like the space elevator, which is probably a non-starter anyway.
Yeah.
So, interesting, really interesting analysis there.
Indeed. It's not good to finish on a downer like that, but for all their achievements, there is a price to pay, and it sounds like our atmosphere is paying that price, and will do for some time to come unless something can be done about it, and there's an alternative on the horizon, but it doesn't appear to be the case. If you want to read that story, as Fred said, it's on the space.com website, and that story about the SpaceX launches is at phys, P-H-Y-S, phys.org. And don't forget, if you would like to contact us or visit our website, you can do that at spacenutspodcast.com or spacenuts.io and have a look around. Christmas isn't far away. Maybe you want to get somebody a nice space-related gifty poo. We've got them at our shop. And if you want to be a supporter of Space Nuts, don't forget to click on the supporter tab and maybe become a patron. We're not telling you to. We would never tell you to do that, but it's an option. And we certainly send our thanks out to the several hundred members of various patron based websites who support Space Nuts. We really do appreciate it. Thank you so very much. Lots of benefits come with being a patron, which Hugh looks after. So that's all on our website, spacenutspodcast.com. Fred, we're all done. Thank you so much, sir. Nice to talk to you again.
And you, and we'll speak again soon.
I'm sure we will. Could be a few minutes, could be a few days. You never know. Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio for... I'll get back to you on that. And from me, Andrew Dunkley, thanks for your company. We'll catch you again on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.